Subject: transmission and distribution. Topic: grading of cables. That is very important topics. G. Grading of cables. G is equal to V divided by X log R2 divided by R1 per meter. Grading: the process of achieving uniform electrostatic stress in the dielectric of cable is called as grading of cables. There are two methods of gradings: capacitance gradings, intersheet grading. Capacitance grading: the process of achieving uniformity in the dielectric stress by using layers of different dielectrics is known as capacitance grading. In capacitance gradings, the homogeneous dielectric is replaced by a composite dielectric. The composite dielectric consists of various layers of different dielectrics in such a manner that relative permittivity of any layer inversely proportional to the distance from the center. The capacitor grading diagram shown in figure and shown in notes. There is small diameter d by 2 and d1 by 2 and d2 by 2. A large diameter capital D by 2. G maximum is obtained from waveform. G is y-axis. Under such conditions, the value of potential gradient at any point in the dielectric is constant and is independent of its distance from the center. In other words, the dielectric stress is the cable is same everywhere and the grading is ideal one. However, ideal grading requires the use of an infinite number of dielectric, which is an impossible task. In practice, 2 or 3 dielectrics are used in the decreasing order of permittivity. The dielectric of highest permittivity being used near the core. ER proportional to 1 by X. ER is K by X. Potential gradient at a point X meter from the center is given by Q divided by 2 by epsilon naught X. That is Q divided by 2 by epsilon naught K. The capacitor grading can be expected by referring to figure. The capacitance grading can be explained by refer to figure. There are 3 dielectrics of outer diameter D1, D2 and G and of relative permittivity epsilon tau. Potential difference between cores and lead, that is earth sheath, is given by V. Capital V is equal to V1 plus V2 plus V3. V formula is given in notes, shown in notes. As the permissible values of G maximum of the peak value, therefore all the voltages in above expression should be taken as peak values and not the RMS values. Note 2, if the maximum stress in the 3 dielectrics is not the same, V is equal to G1 max divided by 2 D log E D1 divided by D plus G2 max divided by 2 D1 log E D2 divided by D1 plus G3 max divided by 2 D2 log E capital D divided by D2. V formula is shown in notes. Capacitance of component cable is given by C. C is equal to Q by V. That is, C formula is shown in notes in 9th page. Note 3. If the cable has homogeneous dielectric, then for the same values of small d capital D and G maximum, the permissible between core and lead sheath would have been V dash is equal to G max divided by 2 D log E D by D. Obviously, V greater than V dash, that is the given dimensions of the cable. The graded cable can be used at a greater potential than non-graded cable. Alternatively, for the same safe potential, the size of the graded cable less than that of the non-graded cable. The main disadvantage of this method is that there are few high-grade dielectrics of reasonable cost whose permittivities vary over the required range. Intersheath grading. In this method of cable grading, yes, homogeneous dielectrics is used, but it is divided into various layers by placing metallic intersheaths between the core and lead sheath. The intersheaths are held at suitable potential which are in between the core potential and earth potential. This arrangement improves voltage distribution in the dielectric of the cable and consequently more uniform potential gradient is obtained. Consider a cable of core diameter D and other lead sheath of diameter capital D. Suppose the 2 intersheaths of diameter D1, D2 are inserted into the homogeneous dielectrics and maintain its same fixed potentials. Let V1 and V2, V3 respectively be the voltage between core and intersheath 1, between intersheath 1 and 2, and between intersheath 2 and outer lead sheath. As there is a definite Essential difference between the inner and outer layers of each intersheath. Therefore, each sheath can be treated like a homogeneous single core cable. Maximum stress between core and intersheath. One is G1 maximum is equal to V1 divided by D by 2 log E D1 divided by D. G2 max and G3 max given in note. Since the diode is homogeneous, the maximum stresses each layer is the same. That is G1 maximum is equal to G2 maximum is equal to G3 maximum is equal to G maximum. As the cable behaves like three capacitors in series, therefore all the potential are in phase. That is voltage between conductor at the lead sheath is V is equal to V1 plus V2 plus V3. Lead switch diagram is shown figure shown in notes. That is intersheath 1 and intersheath 2 lead sheath and center is core or conductor. G maximum versus X axis. Intersheath gradient has three principal disadvantages. It is difficult to fix the potential of H. Intersheaths may damage during transportation and installation, therefore losses in the intersheath. For this reason, intersheath grading is rarely used.